Welcome. This is Coach Dorf. We're in section 4.1 and we're looking at a homework example. In this one, we're supposed to find the critical numbers of a given function. So let's first review what is a critical number. So a critical number of a function f is a number, is an x value, x equals c, in the domain of f such that the derivative there equals 0 or the derivative does not exist. Okay, so let's look at our function here. We're given f of x equals x to the 4/5 times parentheses x minus 4. So I need to find the derivative here. All right, so what is the derivative? How can I do the derivative? Well, there's two ways to do this. So first we're going to find the derivative. I think a lot of people, the first method they would use is to use the product rule. So to do the product rule, to find the derivative, I'm going to get the derivative equals the first term, x to the 4/5, times the derivative of the second term, plus the second term times the derivative of the first term. All right, so then I got x to the 4/5. The derivative of x minus 4 is just 1. And then I have the second term. Now the derivative of x to the 4/5 by the power rule is 4/5 x to the negative 1/5. Remember, I'd take 4/5, I subtract 1 from it. So 4/5, just do this off to the side here, 4/5 minus 1 equals 4/5 minus 5/5, which equals negative 1/5. Okay, that's how we get this exponent right there. Okay, now we're going to simplify this a little bit, combine terms. So I get x to the 4/5. So now I'm going to distribute this 4/5 x to the negative 1/5 to the two terms inside the parentheses. So first I'm going to get x to the first times 4/5 x to the negative 1/5, and then I have minus 4 times 4/5 x to the negative 1/5. All right. Now, what is this x to the 1 times 4/5 x to the negative 4/5? Well, that's going to be 4/5. What's going to be my exponent on x? Well, I have a 1 and I have a negative 1/5. I add those together. 1 minus 1/5 is going to give me a 4/5. And then for the next one, I'm going to combine these together to get 16/5 x to the negative 1/5. And then my first two terms have the same x power, so I'm going to add those together. So I have 1 plus 4/5, that's going to be 9/5 x to the 4/5 minus 16/5 x to the negative 1/5. Okay, that is then the derivative, one way. Another way we could do this is to multiply first and then use power rule. All right, so again, let's see, our original function was f of x equals x to the 4/5 times x minus 4. So we're going to multiply through by this x to the 4/5 into both terms here. So I'm going to get x to the 4/5 times x minus 4 x to the 4/5. And this x to the 4/5 times x, that's x to the first. So I'm going to add those exponents together. So I have 4/5 plus 1. That's going to give me x to the 9/5 minus 4 x to the 4/5. Now I'm going to do the power rule. So x to the 9/5, power rule, bring out the 9/5 out front, x. I subtract 1 from 9/5. So I have 9/5 minus 1. And then here I've got, the second term, I've got negative 4 out front. I bring the 4/5 down, and I have x to the 4/5 minus 1. There. Then let's simplify this. So it's 9/5 x. And now the exponent is 9/5 minus 1. Okay, that's going to be 4/5. And then here I have 4 times 4/5, so it's going to be minus 16/5 x. And then I have 4/5 minus 1, which is what we did up here earlier. I'll mark this in red or purple here. That was negative 1/5. So this part here, go up here. We see that that's negative 1/5. So I'm going to get negative 1/5 there. I'll go back to this. And so notice I get this part, and what we did above, which I'll circle in red here, we get the same answer either way. You can decide which method you like. I kind of prefer the second one, but both work. All right, now to find, we're going to find the critical numbers, given that we have the derivative. So I think the first thing to do on this next step would be that I'm going to take the derivative and I'm going to rewrite it as a fraction. All right, now how can I do that? Well, I'm going to factor out an x, and the question is, how many x's do I factor out? My rule of thumb is always factor out the number of x's to the smallest power you have there. So we have here x to the 4/5, and we have x to the negative 1/5. Negative 1/5 is smaller than 4/5. So I'm going to factor out that many x's. All right, so I'm going to have x to the negative 1/5 that I'm going to factor out. I'm also going to look at the coefficients out front. I have a 9/5 and then a negative 16/5, or a subtraction of a 16/5. They both have a 5 in the denominator, so I'm going to factor out that 1/5, get rid of the fraction part of it. So what am I left with? Well, I have 9 here, because here, this 1/5 times 9 is going to give me the 9/5 I have up here. And then I have x. And what am I left with here? Okay, well, it's got to be that when I take 4/5 and I factor out a negative 1/5, what I'm doing is I'm going 4/5 minus a negative 1/5. All right. And let's see, on the second part here, again, I factored out in green, I factored out this 1/5, and I had 16/5, so I have 16 out front. And I factored out an x to 1/5, and so I'm just left with that. So now I can rewrite this as 1/5 x to the negative 1/5 and 9. And here in purple, what does that exponent equal? So that's 4/5 plus 1/5, that equals 1. And so now I'm left with x to the 1 power minus 16. And now I'm going to rewrite this as a rational expression or a fraction. So I have 9x minus 16 on the top. The 1/5 out front is the same as putting a 5 in the denominator. And x to the negative 1/5 is the same thing as putting x to the positive 1/5 in the denominator. So this is what my derivative looks like. And this is much more useful in trying to figure out when the derivative does not exist and when the derivative equals 0. So first, when does f prime not exist? Well, that means, going back to the same thing, it's like, what are the restrictions on the domain? When do you have a restriction on the domain? Well, you have it if you've got a 0 in the denominator, if you've got a negative number under square root, or if you have a log of a parentheses term, what's in that parentheses can't be negative or 0. Well, we have no logs, we have no square roots here. Okay, all we have is x to the 1/5, so that's an odd root, so we don't have to worry about negatives. But we do have x in the denominator. So we have x to the 1/5 in the denominator. we could get 0 in the denominator if x equals 0. So x equals 0 implies that f of x does not exist, because then we have, if we have that case, then we have 0 in the denominator. All right. Second, when does f prime of x equal 0? Well, there, all we need to do is now look at the numerator and set that equal to 0. And if I solve for that, bring the 16 over to the other side and divide by 9, I get x equals 16 over 9. All right, so I have x equals 0, x equals 16/9. So my critical numbers are x equals 16/9 and 0. Okay, one thing I needed to check on here, okay, that I didn't mention, but it's really important, is x equals 0 in the original domain. If I go back to the original function here, here's my original function. Do I have any restrictions there? Can x equal 0? Yes. Okay, no problem there. I would have x couldn't equal 0 if x were in the denominator, but there is no denominator there. And I have no x to the negative power that could give me an x in the denominator. So I'm okay. X can equal 0 in the original domain, but when I took the derivative, we saw that I do get an x in the denominator, and so the derivative does not exist at x equals 0 in that case. So it is a critical number. All right, so the key steps on this one, when you have a function with a fractional exponent, you take the derivative, factor out x to the smaller exponent power, all right, and then rewrite it as a rational expression, something over something, all right, and then check to see when the numerator equals 0, because that will be when the derivative equals 0, and then also see if the derivative never exists at certain places, and that's where you might have something in the denominator that could equal 0. Hope that helps.